What's up guys, how's it going? Well, in this video here, you're probably wondering, what the hell am I doing? Why do I have two motors connected together? Well, an idea going around YouTube that you could connect two motors together and you can get them to self-run. Well, basically this video here is just a demo on, I have two motors connected together and we're just going to see the results. Of course, their videos are a little different. So self-running means basically the drive motor is going to turn a generator, and then the generator is going to provide enough energy plus, and then it's going to flow back into the drive motor. So, and then we'll have a continuous loop. It's basically you're connecting them together. Apply a current to it to get them spinning. And then once they're up to speed, they stay at a constant speed, or they'll increase speed or whatever. All right, so what do I have here? I have two cooling fan motors from GM cars. They're basically identical. They're permanent magnet motors. They both have armatures and commutators and brushes. What I'm going to do is I'm going to hook them up individually first, and we're going to get the rotation, the same rotation of each motor to check to see if both motors are going to be spinning the same way. I'll try connecting them together and apply current to it and then see what happens.
I'm only working with low voltage in this video, so you might see some sparks, but that's basically just the current.
Low voltage, so don't worry.
I have modified the motors a little bit. I've disconnected the brushes inside from the ground, the casing of the motor, so both of them are isolated.
I'm going to start up each motor individually and let's get the proper rotation. So this motor here, this one's positive on this motor, and we'll try this one here. We want them to spin the same way, so okay, so that's wrong.
This one's the negative, and this one's the positive.
So now both motors, you can see that they power up individually. Both motors are connected together. We have the two positive wires and the two negative wires. So let's turn it on and see what happens. And let's see if we can get this thing to self-run. I kind of already know what's going to happen, so run. We can see that it's not working. So now what I'll do is I'll individually connect a motor and then we'll see how it slows down. Now you can see that this one here is actually a more powerful motor. The idea here is to have a lower wattage motor turning a more efficient generator so that it'll put out more power. But unfortunately, even if I connect them together after it's running, nothing. We won't give up on this yet, and I have some capacitors here, so let's hook them into the system and see what happens then.
Capacitors here, they're not like the new capacitors of today, like the super caps, but there's still quite a few of them here.
If I charge up the capacitor bank and then touch it to one of the motors, it runs for a split second. I'm going to attach the battery up with the motors connected to the capacitors, and let's see. Disconnect. It's running a lot longer, but we're just using the stored energy from the capacitors. So now what I'll do is I'll attach both motors together, and then I'll get them running. We'll connect the capacitor bank up, so I'll connect the capacitor bank up. Disconnect. No. Try it again. Capacitors are charged. Start the generator here, start the motor. Uh-oh. Connect up the... That didn't sound too good. So you can try this if you want. You can connect all kinds of different motors if you want and see if it'll work. So in my opinion, conventional motors like this, or generators, or anything like that is not going to work. It's not going to self-run.
I have some halogen bulbs here. Each one is 51 watts. They're rated at, and that's what it says on the bulb. So what I'm going to do is I'm going to turn on the drive motor here, and we're going to then hook up these bulbs to the other motor, which is the generator.
So fire it up. That light up one bulb, and if you listen, you'll hear the drop in RPM. So that's 50 watts. So let's connect them together. That'll be 100 watts. See here that we have quite a load on here. It slowed it right down. So also you might have heard people using the word over unity. Now basically that means that you're going to put less energy in than what you're going to get out. So you're going to have more energy out than what you put in. And basically that's what you'd have to make this self-run. You'd have to have it over unity. So later on in the video I have this motor here hooked up, and you can see how that one operates connected up to the generator here. I'm going to attach it to the generator here and see what happens. Now, is there any point to this? Not really, but it's just for fun, so let's see what happens. Let's start it up. And there we go. That just switched off. What happens when I try to stop this motor? We're going to find out. The whole thing starts slowing down. Will it actually come to a stop? Nope. The bulb's hooked up to the blower fan motor here. It's a permanent magnet motor, so this one's our generators. Slows it right down. If I short out this motor here, you'll see basically what magnetic braking or regen does. So it stops pretty quick. So basically to self-run, you need more energy out than you're putting in. So there's a little bit of a problem there. The thing is people are saying that you can use a big giant flywheel, or they're saying that you can use a larger generator and a smaller motor to get it going. Well, even if you had a massive flywheel, it might self-run or look like it's self-running for a while, but eventually it's going to start slowing down. Unfortunately, that's my prediction of a lot of these motor generator setups. We have bearings on these motors here, and we have bearings on this motor that we're using as a generator. So we're not going to get 100% efficiency when we spin this generator here, because we're going to have heat loss from the bearings, so we're losing energy. So this video here is not a video to discredit or to say that this isn't possible. Basically, this is just a working demonstration with two motors. Fortunately, we just can't get these motors to self-run, but yet I'm still open-minded to this. So I'm not trying to debunk anything. I'm not trying to say that these people are tricking you, but there is a lot of videos out there that are sort of leading you to believe that it's working, but it's really not. They're just connecting little tiny thin wires where you just can't see the wires. So, but I'm not trying to say it's impossible. So keep experimenting. You never know one day, but you don't want to put too much effort into something that you know that won't work. So you might as well try to come up with different ideas. This is just a demo. I already knew what was going to happen with this because when I was a little kid, I already tried connecting two motors together, and I was never able to get that to work. So unfortunately, maybe these other people are doing something I didn't know. So, but anyway, this is just a demo, and thanks for watching.